All right, let's jump into a topic that's absolutely critical for your NEET physics prep, derived units and unit conversions. We're going to break down exactly how to handle these with confidence so you can stop making those common mistakes and start locking in those valuable marks. Let's get right to it.
So let me ask you something. Think about all the practice problems you've done. Where did those silly mistakes always seem to pop up? You know, the ones that turn a totally correct method into a wrong answer. It's not always the super complex physics, is it?
Yep. More often than not, this is the culprit, mismatched units. It's such a common trap. You're given data in, say, centimeters, but the formula needs meters. You forget to convert, and boom, the whole calculation goes off the rails.
So to fix this, we've got to understand where the problem even comes from. And it's pretty simple, really. A long time ago, scientists all over the world just came up with their own ways to measure things. And this right here shows you the three main systems you're likely to see. You've got the CGS system, which uses centimeters, grams, and seconds. Then there's the FPS system, foot, pound, second. And finally, the one you'll use most often, the MKS, or SI system, which is the international standard, meter, kilogram, and second.
Now let's talk about the building blocks. No matter which system you're using, they're all made from two types of units, fundamental and derived. Nailing this difference is totally key to understanding everything else.
Okay, so fundamental units are your absolute basics. The best way to think of them is like the primary colors of measurement. In the SI system, there are 7 of them, like the meter for length, the kilogram for mass, and the second for time. They stand on their own and are the foundation for, well, everything.
So if fundamental units are our primary colors, then derived units are what you get when you start mixing them together. When you multiply or divide the fundamental units, you can describe more complex things, like velocity, right? That's just length divided by time, or meters per second. Force is a mix of mass, length, and time. In this quote, it sums up the whole idea perfectly. It doesn't matter how complicated a physical quantity looks, you can always break its unit down into those fundamental building blocks. This is the big idea that makes unit conversion and dimensional analysis even possible.
Okay, theory's great, but let's get our hands dirty. We're going to walk through a typical conversion problem step by step so you can see a foolproof way to solve these every single time.
Here's our mission. This is a classic exam-style question. We're given the Young's modulus of steel in SI units, that's newtons per square meter, and our job is to convert it into the CGS system's equivalent, which is dynes per square centimeter.
The trick here is not to get overwhelmed by the whole thing at once. We're just going to break it down. Our strategy is simple. Isolate, convert, and then recombine. We'll handle the force part first, then the area part, and then we'll put it all back together. Easy.
Let's start with the top part, the numerator, which is force. In SI, it's the newton. In CGS, it's the dyne. Now this is one of those conversion factors you should probably just memorize. 1 newton is equal to 10 to the power of 5 dynes.
Okay, now for the denominator, area. We need to go from square meters to square centimeters. And listen, you have to be careful here. We all know that 1 meter is 100 centimeters or 10 squared centimeters, but we're dealing with area, which is squared, so you have to square the entire conversion factor. That means 1 square meter is 10 squared squared, which gives us 10 to the power of 4 square centimeters.
And now for the easy part. We just put all our pieces back together. We take our original number and we multiply it by our conversion factors. We swap out newtons for 10 to the 5th dynes on top, and we swap out square meters for 10 to the 4th square centimeters on the bottom. So what happens when we simplify the math? We have our original 10 to the 11, and that gets multiplied by another 10, because 10 to the 5 divided by 10 to the 4 is just 10, and that gives us our final answer, 1.9 times 10 to the power of 12 dynes per square centimeter. See, when you break it down, it's not so bad.
Awesome. So we know how to do the calculation, but how do we make this a rock-solid strategy that saves you time and prevents mistakes on the actual NEET exam? Let's talk tactics.
Your absolute best friend here is dimensional analysis. Seriously, think of it as your safety net. After you finish any calculation, you can do a quick check to see if the fundamental units on both sides of your equation actually match up. If you're trying to find velocity, but your final units are something weird like meters per second squared, you know immediately that you messed up somewhere. It's a lifesaver.
So here's your 3-step game plan to make this foolproof. 1. Before you even think about calculating, convert everything into one system. Just make it a habit to use SI units. 2. Once you have your answer, do that quick dimensional check we just talked about. And 3, memorize a few of the most common conversion factors, like 1 joule equals 10 to the 7 erg. Trust me, this will make you so much faster and more accurate.
And that's really all there is to it. That's how you take something that trips a lot of people up and turn it into one of your strengths. Which leaves us with a pretty cool question to think about. We've seen how dimensions can check our work, but what if you could use them to actually build new formulas from the ground up? It's a powerful idea. Thanks so much for joining me.